Hello, Algebra 1, Algebra 1 Essentials lovelies. Oh, I have trouble getting started. It's your favorite math teacher ever, Miss Waite. How are ya? I hope you're well. Hey, if you have a piece of graph paper, it would be super sweet if you would plot the coordinates from this table and then connect the points. If you don't have graph paper or you totally don't know what I'm talking about, just hang on. All right. So the last time we chatted, we were talking about functions. And functions are a particular kind of thing. Functions are a type of equation that are very, very predictable. Every time you stick something into that equation, you get exactly one thing back every time. And that's why people like to use them to make predictions or to discover patterns, because they're reliable. You're not going to stick something in and not know where it ends up. So functions are great. We're going to continue to talk about functions, and then we're going to talk about how you can use them here in the future. But what I wanted you to be reminded of in this warm-up is that all of these things, graphs, points, functions, all of these things are related. So when I say plot coordinates from the table, notice that there are x values and there are y values. And hopefully this is kind of familiar from this kind of thing, when you have x and y's and a point, and you can plot that on a graph, because you go a certain amount left and right, and then you go a certain amount up and down, and make a dot, and there you go. So when you're looking at plotting coordinates from a table, you've got an x value, and that's how far you're going to go left and right, and then you're going to have an associated y value, and that's how much you go up and down. And this could also be written like this. It's just in a table instead. So that first point, you go from the middle, the 0, 0, which is right here. It looks like you're going to go 1 unit to the right and 4 units up. So 1 unit to the right, and then 1, 2, 3, 4 units up goes right here. That's where that dot lives. Now this 2, 8 could also be written like this, 2, 8. It just tells you go 2 units to the right and 8 units up. And so starting at 0, 0, we go 1, 2 to the right, 1, 2, 3, 4, 5, 6, 7, 8 up, right there. Now the next one is 3, 12. So we're going to go 3 units to the right, 1, 2, 3, and 12 units up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the last one, 4, 16, 4 units to the right, and 16 units up. Well, okay, there's 12, 13, 14, 15, 16. There it is. And then it says, then connect the points. And so I'm going to try to do that as straight as I can. Oh boy, this is going to be tricky. I think I have like a line function on this thing, but I don't know where it is at the moment, so I'm just going to try my best. Here we go. Oops, I missed the last one, but there we go. We connected it. Great. So that's what that looks like. You could have a table like you have. Each point in that table could be written as coordinate points. You can put those coordinate points on the graph, and then you can connect them together. That's what this looks like. So I'm going to do the same thing, but with this one, this second one. So I need a point at 3, 2. So 3 units to the right, 2 units up. 3, 2 right here. Looks like I need another point at 4, 1. So 4 units and then up 1. I need another one at 5, 0. Here's 5, and then nowhere up and down is 0. And then 6, negative 1 is right here, and we can connect these. Be a little easier to connect this one because it's kind of close together. And I'm going to put arrows on either side because you should. All right, so when I took these points in both cases and I put them on that graph, I was able to connect them in the form of a line. And for every input, I had exactly one output. I didn't have any repeated 4s. 4 went to the 1. It didn't go anywhere else. This is how we know that these are functions. Lines are functions. When we are talking today, we're going to be talking about a particular type of function called the linear function and how you can tell if it's a linear function or a nonlinear function. When you have a graph, it's pretty easy. Is it a line? It's a linear function. But from tables, it's a little bit trickier. So before we get there, though, let's work on that notebook. Pause this video, write some questions for your last set of notes, write a summary, get a page ready for today's notes, wrap your head around that math for a little bit, get into math brain, and then let's talk about linear functions. All right. Essential question, how can you determine whether a function is linear or nonlinear? In other words, is it a line or isn't? Topic, identifying linear functions, also should go into your table of contents. So let's do this. So the idea is that if we know that a function is a line, we can really do a lot of work with it, because once we establish a pattern, we can continue that pattern forward and make predictions, or we can back up that pattern and see what has come before that set of data. So linear functions are super, super useful, and that's why we study them. So I've got a couple of things to tell you about. First of all, a linear equation in 2 variables. We're used to equations with 1 variable, like x or r, or just 1 variable at a time. But a linear equation will have 2 variables. A linear equation in 2 variables is an equation that has 2 variables and its graph is a line. 2 variables and its graph is a line. Now a classic example of this is y equals mx plus b, which you might be familiar with. It has the variable y and it has the variable x, and every time you look at y equals mx plus b, it ends up being a line, and we're going to look at that a bunch in just a bit here. So if it's not familiar to you, don't worry, we'll get there. But that's a classic linear equation in 2 variables. A linear function is a function that makes a line. And these are great. Linear functions are very cool. And then non-linear functions are also great, but we want to be able to tell the difference. A non-linear function is a function that does not make a line. Linear means line. It actually has the word line right in it. Linear means line. So a linear function is a function that makes a line. When you look at its graph, it's this nice pretty line. And a non-linear function is a function that does not make a line. Pretty simple idea. So when we're trying to tell the difference between a linear and a nonlinear function, if you have a graph, it's pretty easy to tell. Because like in A, notice that that's not a line, which means that it is a nonlinear function. As soon as you know it's not a line, it's nonlinear. Now B is a line, so this is linear. It really is that simple. It really is. Believe me, that's it. When you take a look at the graph and you have a line, that's a linear function. When you take a look at a graph and it's not a line, it's a nonlinear function. Done. What about number 1? Is that a line? Yes, it is. And so this is a linear function. Now, what about number 2? It's a little bit trickier because you want to feel like it's a couple of lines. They are straight, but that's not a line. You have to look at its whole thing, and it's actually like more of a V. And so this is nonlinear. Only when it's actually a line, and only a line, is it linear. All right, so looking at not linear, nonlinear in graphs is kind of the easy part, but we want to know if a table represents a linear or nonlinear function. So the key thing, here's the key idea. See how the y values change. That's what you're going to do. So when we take a look at number 1, we're going to see how the y values change. In other words, as these x's go up, this one goes up plus 3. It also goes up plus 3. This goes up plus 3. As these change by 3, do the y's also change consistently? So when we get going from 36 to 30, we've subtracted 6, correct? Going from 30 to 24, we've also subtracted 6. Going from 24 to 18, we've also subtracted 6. And because the y values change in the same way, this thing is linear. Because the y values change in the same way, that is a table of a linear function. Here's one that isn't a linear function. Now notice the x goes from 1 to 3, and that's going up by 2. And then it goes up by 2 again. And then it goes up by 2 again, right? So the x's are consistent. You're going up by 2 every time. But look what's happening in the y place. In order to get from 2 to 9, you have to add 7, correct? But in order to get from 9 to 20, you have to add what? 11. And then to get from 20 to 35, you have to add 15. And so you see how the y values are not changing in the same way. You have to take a bigger step every time. This means this is nonlinear. So as the x values are consistent in number 1, you're going up 3 every time, the y values go down by 6 every time, which means it's linear because the y values change in the same way. That number is consistent. But it's nonlinear when your y values change in a different way every time. 7, then 11, then 15, nonlinear. As long as the y values change in the same way, then your table is showing you a linear function. All right, so let's try this again. Does the graph or table represent a linear or non-linear function? Well, let's see. The x's go up by 1, and then goes up by 1 again, and goes up by 1 again. So the x's are consistent. That's good. Now let's check the y values, though, because that's what's really important. Going from 3 to 5, we had to add 2, right? Going from 5 to 7, oh, we also had to add 2. Going from 7 to 9, we had to add 2. And because you get the same number every time, this is linear. Now let's take a look at number 2. X goes up by 1, x goes up by 1, x goes up by 1, okay. But what about the y's? In order to go from 16 to 8, we had to subtract 8. In order to go from 8 to 4, we had to subtract 4. Uh-oh. In order to go from 4 to 2, we had to subtract 2. And because this y difference, this y change is different every time, this is nonlinear. And that's how you can tell. So let's recap. In graphs, it's easy. If it's a line, it's linear. If it's not a line, it's not. Simple as that. In tables, it's a little bit trickier because you have to figure out how things change. But if your y values change in the same way, then it's linear. If they're not changing in the same way, nonlinear. Y values are the same, linear. Y values aren't the same, nonlinear. I mean, why change? I mean, why change, right? All right, you guys, that's all there is to it. That's how you can tell the difference between linears and nonlinears. Your practice is on Big Ideas Math. I hope that you ask for help if you need it. And I also hope you have a wonderful day. See you next time.